Hi all, one more formulas example here. I would like to work a little bit with a radical function. So here we have a square root function. I'm only going to do one thing. I just like to work my way through a difference quotient. It takes a really specific algebra trick to simplify your difference quotient to the point where you can cancel out your original denominator. And I want to make sure to show you that. So again, the motivation might be a little bit lost here. You'll have to hold on till Calc 1 for that. But let's see, let me give you your question and then we'll talk about it. I would like to find f of x plus m minus f of x all over m. Okay, so definitely a difference quotient. Once again, I'm hoping that when you see that, you recognize that you're doing some sort of slope or average rate of change calculation. This is a y value minus a y value on top. Anytime you take f of something, you're getting an output, which is some sort of y value. When you subtract two y values, that's always rise. Because we're working with function notation, it's really easy to see what the corresponding run would be. An x plus m minus an x would give me an m. So the change in x is in fact m, which means when we do this division, we're getting a slope or an average rate of change. Average rate of change here because this is not linear. Okay, so the first steps of this hopefully should make sense. It's just using function notation. So I have two different inputs to give to my function. I'm supposed to then take the outputs that I get, subtract, and divide by m. Okay, so I'm going to start right down here. If I plug x plus m into my function, the rule for this function f is that it triples your input and then takes the square root. So if I give it an x plus m, it's going to triple and then take the square root. This is one of those where the parentheses are important. If you forget the parentheses, the m will not get multiplied by 3, and it should. It's part of the input. So this is my number one. This is the f of x plus m. Number two, I'm supposed to find f of x. That's really easy because x is the variable used in the definition of this function. So when I plug in x into f, I get the square root of 3x, and that's my number two. I'm supposed to subtract and divide by m. Okay, so here, this is what makes this one interesting. Really, just looking at that, I don't think that there's any huge reason to worry much about simplification. But I do know what we're going to want to try and do in Calc 1. And in Calc 1, it's going to be very important to us that we cancel this m out of the bottom. So I'm making you wait until you get there to figure out why we want to cancel that m out of the bottom. But I want to show you the algebra trick now because the algebra is usually what gets people in the most trouble when we're working on this. So if I would like to cancel an m out, I'm kind of in trouble because there's no m's free on the top for me to factor and then cancel. This is the only m I have on top, and it's stuck in parentheses and it's stuck in a square root. So our motivation here, trying to cancel out the m, tells us that we need to get this m out from the parentheses and the square root in some way. The parentheses aren't so hard. We can just distribute the 3x through. And actually, we'd even be fine if we didn't, but we'll go ahead and do it since we said that's one of our goals. The square roots are the tricky part. So hopefully at some point you've talked about rationalizing denominators. Interestingly, we don't really care that much about rationalizing denominators, but here in this example, and when we do this similar thing in Calc 1, we do care about rationalizing the numerator. If we could eliminate the square roots from the numerator, we might have a shot at freeing up that m and factoring it out and canceling it. If we would like to eliminate roots from the numerator, we have to use our trusty algebra trick, multiply by 1. We want 1 disguised in the perfect way so that this top ends up being really nice. Just to point it out, some people here usually say they want to square the whole thing, and I completely understand what you're thinking there. Squaring gets rid of square roots. The problem is, well, there's two problems that I can see right away. One, if you square this whole thing, it changes its value, and we're trying to make sure that this fraction is still equal to f of x plus n minus f of x over m. We're just trying to simplify it. So rewrite it without changing its value. That's what simplifying is here. The other thing is if you square the whole thing, when you square the top, you have to multiply it by itself. And by the time you're through with foiling that out, you're not actually going to have eliminated square roots anyways. So the trick here is what you have to multiply the top and bottom by is called the conjugate. It's the exact same thing we started with in the top, but we're going to put a plus in the middle instead. And basically what we're trying to do here is get a difference of squares sort of effect happening, where when you multiply this out, your inside-outside terms wipe each other out completely, and then all you're left with is the square of the first term minus the square of the last term. So I'm going to do all the steps just to make sure people are really clear. Remember that fraction bar is implying some grouping symbols, some parentheses all the way along. So the top is the messy part. I'm give myself lots of room and see if I can write this out carefully. We have to FOIL. The first is really nice. If we take the square root of 3x plus 3m and multiply by itself, the square root of 3x plus 3m squared is just a 3x plus 3m. So exactly what we would be hoping happens there. The outside is not so nice. I get a square root of 3x times the square root of 3x plus 3m. You can leave that separate, or it's perfectly legal when you're multiplying two radicals to squash them together and just multiply the inputs. So I'm going to go ahead and do that just to remind you of that fact. Not loving it. There's a square root there. My whole hope was to get rid of square roots, but let's continue, see if I can squeeze this all onto one line still. The inside is going to be a square root of 3x times a square root of 3x plus 3m, exactly what we did before, but this time it's going to be a minus, and this is what saves us. So we have a 3x times 3x plus 3m all under our root. Again, if you'd like to just write this out without combining the roots, that's fine. The roots are going to go away, but I do want to remind you that when you multiply two radicals together, you can go ahead and squash that into a single radical. And then the last is also a really nice one, like our first was. When we multiply the square root of 3x by itself, we've got the square root of 3x squared. The square and square root wipe each other out, so we just get a 3x, and then we have a minus plus, so this is going to end up being negative 3x. Okay, and just like the rational in this one, you basically end up pushing a lot of the mess into the bottom. It might not look like that right now. Right now it probably just looks like we made a lot of mess all over the place. But shortly, the top will simplify really nicely for us. The bottom is a little less nice than what we started with. But remember, our goal here is to manipulate the top of this fraction to the point that we can cancel an m out, that we can factor an m out of the top and cancel it. So right now, some actually really great things are happening. If you look at this ugly square root that we've been left with, it appears twice. We have a positive one and a negative one. Since we are adding them together, that's going to wipe itself out completely. This is going to add up to 0. So the middle two terms are actually gone. We also have a 3x minus 3x floating around. That's going to add up to 0, so we can cross those out completely. And really all we're looking at here is the mess on the bottom, m times the square root of 3x plus 3m plus the square root of 3x. On the top, all that's left is a 3m. So I don't even have to factor anything out. We've lost all of the terms except for 3m. The 3 and the m are attached by multiplication, so that is a factored form. I can cancel the m out, and I'm finally done with this mess. So again, I know I'm only giving you part of the story. I'm not telling you why we're so worried about canceling out the m, but the algebra practice is really, really good here. That is by far the hardest part for people when we hit calculus, simplifying and getting through some really ugly algebra. So we're going to practice it now. All right, I think that's the tricky part with radicals. So that's all I'm going to do for this one. Thanks for watching.